All right. We're on what part B, creating rational functions from descriptions and graphs. The first thing we're going to do is make sure, yeah, oh, that I gave you all the right notes. Is it your example number 5? Okay. Okay, cool. Just making sure. You never know. Sometimes I could make a mistake because I'm human, is what you were going to say. Uh, all right. So it's given us all the characteristics, and we got to create our rational function from those characteristics. So we have that the zeros at x equals 4, x equals 0. There's a vertical asymptote at x equals -8, and at x equals -3, you have a 0 at x equals -3. From part B. Listen. Go ahead. Part B. All right. So with this in mind and what you know so far, come up with what you think the rational function is. And we're going to go over it. Really ready? I said to try to come up with it, and I'm pretty sure 72,000, whatever you just said, is not it. Remember that your zeros have to be values that are in your numerator, right? Your vertical asymptote has to come from factors that are in your denominator. So keeping that in mind at least. Um, and then the limit as x goes to negative infinity, r of x equals -2 means that you have a horizontal asymptote at -2. A horizontal asymptote. Here are your puzzle pieces. Piece together. I don't know how to do puzzles. I'll give you 2 more minutes, then we're gonna go over it together. Couple minutes, 60 more seconds to process. Guys, I understand.
That's the first time that the only thing you're saying.
I'm working on the review of something. Oh, yeah.
Yeah, you may have already, yeah, that's the question.
Sure. Is the touchstone college board are you busy making it? No, it's a paper. No.
So this is how.
Yep. All right, let's see where we're at. Okay, so pay attention to what we know. We have to pay attention to the fact that our zeros are x equals 4 and x equals 0. So for sure, when we make r of x in the numerator, I have to have x and I have to have x minus 4. Does that make sense? That's because your zeros come from your numerator, right? And in my denominator, I for sure have to have the opposite of them, x plus 8 and x plus 3. Yes, I did. All right. And then it says a 0 and x equals -3 is in both the numerator and in the denominator. So that's another factor of x plus 3. And then this one is squared. Okay. The last little tidbit that it told us is that our limit as x goes to negative infinity, r of x equals -2. This is describing a horizontal asymptote. This is describing a horizontal asymptote. So if I have a numerical horizontal asymptote, That means that the degree of my numerator and the degree of my denominator are the same. So n equals d, which means that it's just their coefficients, right? So that means I need to have a coefficient of -2 at least. And there's my polynomial. My possible. Hard. So hard working backwards. But it makes sense. We gotta be, if we can work backwards, that means we understand what we did in the previous section. Okay? So again, zeros come from the what? The numerator is what she said. Your zeros come from your numerator. Okay? Your denominator tells you about your asymptote. What type of asymptote? Vertical. Okay? And then your limit as you go, as you increase without bounds or decrease without bounds, describes your horizontal asymptote. Okay? Yes. So this would be the simplest form of what a polynomial would be that fits this description. Oh my gosh. All right. So how do we feel now about going backwards? Here are the pieces, put it together. Here are the pieces, put it together. No questions? All right. So on the next part, I have a hole clearly in the graph. And it wants us to find the following rational function. Find the location of the hole. So if I'm looking for the location of the hole, what do we say in section A? That means we're going to plug the value into the what? The simplest form. Simplified terms. So, what eliminates, and then what am I left with?
X minus 3.
So x minus 3 is eliminated, which tells us that our hole is at x equals 3.
With 2 x minus 1 line x minus 2.
Okay, so that's what I'm left with. So that's what I'm going to use to find the value of my hole. So we're going to use f of 0. Oh, I'm sorry, f of 3. You saw nothing. So we're going to find f of 3. We're going to plug it in. So we get 2 times 3 minus 1 over 3 minus 2. And we get what? We already did this. We get 4 over 1, which is just 4. So the exact location of our hole is f of 3 equals 4. So we're going to write that as a limit. So writing this as a limit would be the limit as x goes to 3, f of x would equal 4. Okay, we're not saying that it equals 4. We're saying that the limit is what it's approaching, right? So from either angle, I'm trying to get to 4, but I did not say that this is equal to 4. All right. Yes. Cool. Let's keep. Huh? To save time. Your blank's already filled in. All right. So when we're analyzing rational functions, these are your 5 key steps. You want to simplify the rational function by factoring. Factor, 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 factor. Okay. The numerator and the denominator. You want to find the zeros of both the numerator and of the denominator. The zeros of the numerator are going to tell you your x-intercept. The denominator are going to tell you your wholes and your vertical asymptotes, correct? If a zero is common to the denominator and numerator, you have a hole in your graph. If a zero is unique to only the denominator, then you have a vertical asymptote. If the zero is only unique to the numerator, you have an x-intercept, aka a root. Those are the main rules that we should walk away being able to figure out. Okay. The next part is you answering in your own words a summary about what did you figure out. So using examples from this lesson, the previous lesson, A and B, you can explain the following. So for equations that produce a whole, what do you notice about the powers on the common factors? We already talked about it. Just gotta make sure you really understood and talked about it. And then the second question that you're being asked is for the equation that produced a vertical asymptote, what do you notice about the power on the common factors? Okay. So looking back over our notes that we just did and looking at the examples we just did, you're going to come up with your own summary. Okay. That's supposed to be in your words, you summarizing your learning. Okay. Not me telling you what to write, but you summarizing your own learning. No. It's just more practice. All right.
You better